Hello, my name is Lewis Tyler, Managing Editor of International Fire and Safety Journal and Fire Safety Journal Americas. Delighted to be at the fire safety event today, where I'm at the ProSense technology stand, and joining me is Zhao Li.
Yeah.
Thank you for joining me. So firstly, could you just maybe explain your role within the company?
Okay, thank you. I'm very honored to have this opportunity to be here to have the podcast with you because you are a very famous magazine. And my name is Zhao Li. I'm the founder of ProSense, and now I'm the general manager and the chief technical officer here. In fact, I'm in charge of the whole company, especially the technical part.
So could you maybe briefly explain, what ProSense technology is and what it does?
Yeah, ProSense, I think you cannot call it a young company because this year is our 10th anniversary, and the technical team, we have been working together for more than 20 years. We make gas sensors, especially the advanced gas sensing solution for application in real world, in real industry, not just for the application in the laboratory. As you know, if the sensor is for laboratory use, it is more easier. But we hope that our sensor can meet the requirement of vertical application. So we are in fact a gas sensor company.
So NFPA 855-2026 highlights some potential challenges and concerns regarding combustible sensors, particularly within battery energy storage system environments. So with that in mind, what are the key environmental factors that, in your opinion, can influence gas safety performance?
Yeah, that's a good question because nowadays the industry or the field related with the lithium battery, like the energy storage system, the vehicles, and the data center, they are very hot because they can solve the problem of the air pollution. Especially the application in energy storage system, the sensors, they meet a lot of challenging factors, like for the energy storage system, there are a lot of silicon be used within the battery, the package, and the tank. The silicon is used for the seal of the system, which will generate a lot of silicon vapor, which is vital for a lot of gas sensors. And the second challenging point is there are a lot of paint uses inside, which will generate a lot of VOC gases. And also, the energy storage system, they are not like we just to buy a CO alarm from the supermarket and we can install at home right away. The energy storage system, after all the components are shipped to the site, it usually takes several months or even 1 year to be put into service. Before the system are put into service, the temperature is very high. Just like our car, when we leave outside, the sun is shining and the temperature can reach more than 85 centigrade. So these total three factors, the silicon vapor, the VOC vapor, and also the high temperature, are challenging to the gas sensor used inside. For the catalytic combustion sensor, they are very easily be poisoned by the silicon. So there are a lot of field application on site. Another sensor technique called semiconductive sensor, they are similar to catalytic combustion sensor. They also has the problem of short lifetime and sensitivity drift and offset drift. All of these are because of the silicon vapor and the high temperature inside.
So given the environmental challenges that you've just discussed there, how do your UL recognized sensors, hydrogen and CO sensors, provide advantages for users?
Okay, our UL recognized sensors, in fact, they are beyond the requirement of UL recognized because the UL recognition, UL 2075, they are mainly for the industrial application. They do not include the testing for the sensors applied for the energy storage system but our sensor has passed the most critical test by the energy storage system suppliers. For a sensor that they can be used or they can survive, they can have a good performance in a certain field, I think the most important is the working principle. Just like I said earlier, the catalytic combustion sensor and the semiconductive sensor, they are not suitable for this application, but we use the fuel cell technology. The fuel cell technology has the DNA of long service life, high accuracy and selectivity. So the working principle is the basis of a good sensor. But even with the same technology, not every sensor can work on site properly because most of the sensor companies, they just buy the catalyst. The catalyst is the heart of a sensor. They usually buy the catalyst from a third party. By this, they cannot modify the performance of the sensor. But ProSense, I think we are one of the seldom sensor companies that make all the catalysts by ourselves. By this, we can modify our catalyst or our sensor's performance according to the vertical application. Just like the BESS, we will modify our catalyst to have the anti-poisoning ability to the silicon and the VOC, and they can withstand high temperature. In fact, our sensor can work between the temperature range from minus 40 to 105 centigrade, which is beyond the requirement of UL 2075. And we can pass the test of silicon poisoning lasted for 1,000 hours. So all of this, I think, because of the right principle and the catalyst we developed.
Can you maybe explain the difference between, solid-state batteries and traditional batteries?
Yeah, there are quite big difference. At first, we use the traditional lithium battery. In this battery, the liquid electrolyte is used. There are a lot of thermal runaway accidents every year. Most of these thermal runaway arise from the flammable liquid electrolyte. Once we use this liquid electrolyte, we cannot avoid thermal runaway totally. So now we all over the world, they are doing the research about the solid-state lithium battery. In this battery, we use solid electrolyte. There are three types, that is sulfide basis, polymer basis, and also the oxide basis. Without the liquid electrolyte, the battery is more safer. The possibility of thermal runaway is quite small. So the big difference is the electrolyte used, and also the energy density is very different, because for the solid-state lithium battery, the energy density is very, very high, and we can just charge the vehicle like we use the gasoline. It's very, very fast. It will take several minutes to charge the car, and it can run for more than 1,000 kilometers. So that's the big difference.
If H2S becomes the primary indicator gas for solid-state batteries, what are the challenges for detecting that?
Yeah, for the hydrogen sulfide sensor used for the solid-state lithium battery, they also face quite a lot of challenging factors. Like for the traditional lithium battery, they are first to be used in vehicles. The solid-state lithium battery, it will be the same, because for the vehicles, the requirements is not so high. If a sensor is used in vehicles, it must be AEC-Q grade. That means the working temperature range is between minus 40 to 105 centigrade. That is very challenging for most sensors. And hydrogen sulfide is a toxic gases. The threshold, alarm threshold is as low as 10 ppm, so the accuracy or the precision must be very high. And the third one is there are also a lot of silicon be used within this battery. The sensor must has the ability of anti-poisoning ability. And the fourth one is that the sensor must has at least 10 years lifetime. So these are the 4 challenging points for the sensor used in this field.
Zhao, I think we've covered a broad spectrum to date. Luckily, for I think anyone viewing this video, we do have a part 2. We'll be catching up, I know, once the fire safety event, which of course we're on your stand now, once the fire safety event is over, we're going to jump on a call and we're going to discuss much more in terms of this topic. But for now, really appreciate your time.
Okay, thank you. Thank you.